Hello, all you people out in Burger Flipper land. What's up? All right, so now Maclaurin series. Now, in a Maclaurin series, where does it center around? Zero. Very good. So 0 is good. So now in this case right here, we're going to start with my function there. So let's start doing my derivative. So it's going to be f prime is
cosine of x.
Negative sine x f double prime negative cosine of x and f triple prime sine x. There we go. All right, so if it's Maclaurin, I center around 0, so therefore x is going to be my 0, right?
Yeah.
All right, so it's going to be f of 0 is 1. F prime of 0 is
0.
F double prime of 0 is F triple prime of 0 is 0. All right, so let's go with this. So now let's start writing these out. So the first thing I write is F of 0. So I'm going to have 1 plus 0 x over 1 factorial, right?
Yeah.
Okay, so it's going to be plus negative 1 x squared over 2 factorial plus 0 x cubed over 3 factorial. Okay, so we have the basic 4 terms, and so because it's a sine or cosine, it's going to repeat, right? Mm-hmm. So the pattern's going to repeat. So let's go ahead. So let's write out my terms that I'm going to have now. If I'm writing out my terms, I get 1, 0 goes away, so it's going to become a minus x squared over 2 factorial, right?
Yeah.
Then it becomes, what's going to go next?
Plus.
It's going to be a plus sign?
Yes. And then it's going to be x to the 4.
Plus x 4 over 4 factorial. Okay, so what's going to be the one after that? Minus x to the 6th over 6 factorial. Okay, I think that's enough terms, right?
Yeah.
So is this alternating?
Yeah.
It is alternating, so therefore, if it's alternating, I need to add an alternating series. So it's going to be the sum. As k equals 0 goes to infinity, I have negative 1 to the k. And what else do we have?
X to the 2k. Yeah.
X to the 2k?
Yeah.
Over 2k.
Over what? 2k factorial? All right, so now that's our guess. What do we got to try and do now? Start plugging in to see what we get, okay? Let's start plugging it in. So now 0, so negative 1 to the 0 is 1, right? Positive 1. X to the 0 is 1. Okay, and 0 factorial 1. So I get 1, there's my first term. And then to the 1, so when k equals 1, so it's negative 1, and that's 2 x squared, and that is going to be 2 factorial, right? Okay, so there it is. So that's going to be my answer for this expansion, finding Maclaurin expansion for this. So we found a series for that function that will converge. Okay, does that make sense? Is that good? Yeah.
Yeah.
Not bad, right? Okay, good. Okay, so now this one right here. Now, take a look at your notes and go to the back page. we have not done any hyperbolic. We haven't. So don't feel bad. I know that, and so what I did is I gave you a hyperbolic slides, basically. So let's see. Okay, table of useful hyperbolic functions. So we're going to use, this is cosine, right? Yes?
Yes.
Okay, it's cosine. So I'm going to replace my cosine h with this. So I'm going to replace with that, and so that's going to help me out here. Because doing the hyperbolic, I don't want to do that. Okay, so now if you notice, I also gave you a couple other things to go along with it that is also helpful. Okay, right here. And what else do we have? Okay, some nice sequences here. Okay, so e to the x plus e to the negative x over 2. Actually, we got this one here too. So, now, see this right here? If you guys remember, I sent out a homework. I sent out the homework and it says memorize, didn't it?
Yeah.
Here it is right here. So, these are the only things you might see. Okay, I went through the AP list. There might be one problem, 2 at the most, that has to do with any of this. With the hyperbolic, okay? So, I'm not sweating it. I'm really not. So, if you see something like this, there's a reason why I'm telling you the book even said memorize. So my list of assigned problems says memorize this table. So we're going for here, right? This one should be super easy now, right?
Yeah, we just look at it.
There we go.
X2K.
Where are we at? All right. There we go. Okay. So it's going to be, and I get what? X.
Plus it's alternating.
Yeah, and it's the
So it's -1.
It's alternating 2.
Yeah.
-1 to the,
Okay.
like that.
No, it's not. The cosine is alternating.
Oh yeah, my bad. I read the wrong one.
Cosine's not
It's
alternating.
not alternating. Cosine.
The usual one, Billy.
All right. Ugh. All right. There we go. Yeah. Is that the right one now?
Yeah.
Okay. So, like I said, I looked through the AP testing stuff and memorize. I know you guys have a lot of stuff to memorize, but, you know, one of those things. Okay, find a Maclaurin series for e to the x cosine x. Find the first terms of Maclaurin expansion for this. Okay, first 5 terms. So what does that mean? Okay, but what am I going to need to do the 5 terms? The 5th derivative, right? Yeah, so I need 5 derivatives to do this now, right? So I have the function,
It says first 5 terms.
right?
Okay, okay. Because when we do it normally, we would eliminate anything that would be 0.
Yeah, and we get the pattern off the rest, right?
Exactly.
So we really didn't need to, so like this we got 4 because I start with the function and go to the 3rd derivative, right? So I go bam, 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 here's my 4. But then I got more because I could see the pattern, right?
Yes.
That's what I was trying to get to, okay?
Okay. I was just curious because if we're going to count the 5th, we wouldn't count the zeros, right?
Yeah, not going to count it. All right, so let's see. So that's going to be a product rule. product rules. So let's go ahead. I'm going to go off to the side. So product rules. So it's going to be e to the x cosine x plus sine negative sine x e to the x. So this is f prime, f double prime, and it's going to be e to the x cosine x minus sine x e to the x, right? And so that's just his first term plus, what's the next term? So it's going to be, oh man, I need more room. I'm going to redo this one. So the first one was easy. Second one, f prime double prime is going to be e to the x cosine of x minus e to the x sine of x. That's this first part. And then do the same thing for the next part. So it's going to be minus e to the x. I'm rewriting it. E to the x. Right? If I rewrite it like that, the pattern's going to be the same.
Yeah.
You can see the pattern a little bit easier. So e to the x sine x. So I get that, and then it's going to be sine x, right? And then it's going to be plus sign, right? And then it becomes minus, right? Minus because that, and then derivative of sine, cosine. So I have minus and a cosine. So e to the x, and then cosine x.
So then we get a ex cosine x and ex cosine x cancel because it's minus. Then becomes minus 2 ex sin x.
Okay, so now what do we get?
Negative 2.
Oh, okay, because we have this, right here, and then I have a minus sign here. Actually, I wonder if I change that. Minus sign. Let's see, e to the x, this derivative, negative e to the x sine x, that's right. And then cosine x, so negative e to the x cosine x. Yeah, that's fine. Okay, so now I have this thing and this thing going away, right? So f double prime is going to be negative 2 e to the x sine of x. Okay, so there's my second. So now let's do third. Is going to give me derivative of this, negative 2 e to the x sine x. Okay, so now it's going to be this, but derivative of sine, cosine. So it's going to be minus. So 2 e to the x cosine x. Okay, not doing anything to that, right? Okay, next one, fourth derivative. F is going to give me this right here, right? So negative 2 e to the x sine of x, and then it's going to be minus 2 e to the x cosine x, right? And then now it's going to be this minus, right? Derivative of sine is going to be, or derivative of cosine is negative sine, right?
Yeah.
So that makes this a plus 2 e to the x sine of x. Right?
Yep.
Okay, and then it's going to be, oh actually I did that too soon, didn't I?
It's fine, just subtract 2.
Okay, yeah, so now it's going to be the next one. So it's going to be minus 2e to the x, right? And then it's going to be cosine x.
So then the pattern is every second time we just
Okay, so let's see. What can I get rid of?
the cosine x. I mean the sine. And then
The signs here, right?
And then those combine.
And so now my f is going to be
Negative 4.
-4 e to the x cosine x. Come on, come on. There we go. Ah, no. My board's not working with me. E to the x cosine x. There we go. Okay, so we got 4 derivatives there, and hopefully with my original function, I have a pattern for this one. Okay, so now, let's take a look. So my first one is supposed to be, and this is Maclaurin, right? So it's around 0, right? So at 0 now, let's take a look. So my function at 0. E to the 0 is 1. Cosine at 0 is 1. Okay, so I start off very good there. So I have page after. So it's going to be 1. Okay, so the next one is going to be, let's see. So the first derivative is going to be 1, right? So right here, so 0. Okay, so this one's going to be 0. This one is, so 1 and 1, right? So this is 1. That piece is 1. This piece is 0, right? 0 and 1 is 0. So I get 1 here, right? Okay, so this is positive. Okay, good. All right, so it's plus 1, right? So that's my function, right? So it's, or my derivative, and it's x to the 1 over 1 factorial. All right, so now we're at the second derivative. Should be 0, shouldn't it? Yeah. Okay. There we go. All right, so it's going to be 0 x squared over 2 factorial. Next one. So that is my second derivative. So my function, first derivative, second derivative, third derivative. So third derivative, plug in 0. So this is 0. This is -2. And it's going to be x cubed over 3 factorial. All right, so we're up to the fourth derivative. So fourth derivative, what are we going to get?
-4.
-4. -4 x to the 4 over 4 factorial. You think I can get another one off that? If I did the fifth derivative?
Well, you already know the pattern, so we don't have to actually take it. We can just look at it.
Is there a pattern? Because
It's every second it doubles and switches. So the sixth term, yes, the sixth term.
so you're saying if I write this out, it would be 1 plus x over 1 factorial minus 2x3 over 3 factorial.
Minus 4.
minus 4x to the 4 over 4 factorial. I think I made a mistake on my derivative somewhere. What's 4 factorial? 6, that's right. 3, that's right. Oh, that's right. I just need one more term. That's what I need. Yeah, everything is right. I just need one more term. The pre-response is on there too. You get it? Okay. All right. So one more term.
Can we go back a page so we can look at the pattern?
Okay. So I thought I made it. I had to double check, but yeah, I'm good.
So let's see. So shouldn't it be 0? Because it should be the second. Oh, it's going to be the first.
So it's going to be that one there, right?
Bx cosine x. It's just going to be the first derivative, but 4 instead of 1 and negative. So it shouldn't be.
Should be plus 4 sine x, right? Yes. So, fifth derivative. That's going to give me negative 4e to the x cosine of x, and it is minus plus 4e to the x sine of x. All right, so what do we get there? We get what? Negative 4. Okay. All right, that should be it.
So now we have to find what.
Let's see what it comes out to be though. Okay, so it's gonna be 1 plus x
That should be it.
minus x cubed over 3 minus x fourth over 6 minus 5.
It's just 6 times.
30. Because it's, this is going to be 4 over 1 times 2 times 3 times 4 times 5, right?
Yeah.
So I just basically looked at it and said, oh, it's 5 times 3 factorial. And that's one way of doing it. Okay, plug and chug, right? Looking at it, seeing what we get. It's not that bad. The derivatives kind of got wonky. But I have my first 5 terms here.
The other problem is it skips from 1 to 3.
Okay, but yeah, but I don't have to make the thing out of it. Just give me the terms. That's all I ask for. Ask for the terms.
Oh.
Oh.
Well, that makes it easier.
Okay.
So it's basically saying that the pattern would be over here, right? So if the pattern's over here, you can get kind of iffy with it. Or how about if I go something like this, like f of whatever the sum of those are. Because the pattern doesn't start until later, does it? Remember when we were talking about this the other day, and we were saying, hey, you know what, the first couple terms don't always have to be inside the upper bound and lower bound, right?
Yep.
First couple terms, so if the pattern, so it's bounded above here, bounded below here, so first terms are not part of that, excuse me. I can try and do it something like this. Okay, but it only asks for those, and I don't want to try and do that because that looks ugly. Because trying to get the 2, the 4, the 4, I don't know. Yeah. Anyway, all right. Okay, so now we're going to expansion. Maclaurin series for this. Yes.
I have to leave.
Okay. Now, did we already do sin x?
Yes.
Okay. If I already did sin x, what can I do with this instead? It's no longer x. What would it be? Two x? It'd be 2x, wouldn't it? All right, so let's take that previous one from the other example of the sin x, right? So this is going to be, what did sin one start with? Did it start with 1 or did it start with x? Okay, there we go. Ah, too much. Right there. So my first term should be x, right? Say yes.
Yeah.
So if I'm substituting, my first term is going to be 2x. All right, so it's going to be 2x plus, what's going to be the next term? What was the next term? X cubed over 3 factorial. So, but if it's x cubed, That's going to be 8x cubed over 3 factorial, right? Next one. X to the 5th?
Yeah.
So x to the 5th, right? So now it's going to be 2 to the 5th power, which is 32, x to the 5th over 5 factorial. So we don't have to redo all of our work every time for something that we already did. We could just substitute it back in if it's going to be something different. Because we're just putting it in, and then I did the whole thing for this, but now my expansion is just going to have to do with it's twice as much. Or when I'm doing this, it's 2x, it's twice the angle of what I'm doing.
Yeah, that's alternating.
Hmm?
Yeah. It alternates.
Oh, is it alternate? I'm sorry. If it's alternating, what was my signs?
So between 2x and that's right there.
Here?
Yeah.
Okay, so is it a positive?
So
And then negative?
yeah.
Yep.
And then positive, right? Okay, alright. Understandable? Okay, not too bad, right? Okay, so now we're going to do a Taylor series. Now, in this case right here, it's going to be an x minus c, and now it's going to be x minus 2. Or pi over 2.
Okay, good.
Ah,
I was really
man, I said it with such confidence too that I was like, okay. So about pi over 2. So now this whole thing is, instead of plugging in 0, we're now plugging in pi over 2, right?
Yes.
Good. So now let's go through by derivatives. It's going to be f prime is negative sine x. F double prime is negative cosine of x. F triple prime is sine x. Is that all we need? Basically. Alright, so it's about this. So now it's going to be f of pi over 2. So sine at pi over 2. So this is going to be negative 1 now. Okay, so f prime at pi over 2, 0. F double prime at pi over 2. It's going to give me 1. And f triple prime pi over 2.
Wait, should it be?
Wait, yeah,
Yeah.
I counted it.
I think Woody accidentally did,
Yeah, it should be
Okay, function
0 and then
negative 1, 0. Cosine at pi over 2 is 0, right?
yeah, but that's
Yeah,
F double.
but that's F double prime.
Oh, you're right, you're right. Sorry, thank you, thank you.
It just
Yeah.
moves.
Cosine, so it should be 0. So, thank you. Man, those people flipping burgers while we're watching right now just freaked out. They just cringed over this.
They dropped a couple.
I know, you just dropped a frozen patty on the floor right now. Don't worry, 3-second rule, 3-second rule, alright?
Don't worry, if you fry it, it'll kill the germs.
I know, fry it, you kill all the like fungus that's on the floor. Anyway, alright, cosine pi over 2 is 1. Where are we at?
No, it's zero.
No, it's 0.
0, thank you.
Another patty.
0, another patty fell. Alright,
And then
f
it's negative
prime.
1. Then it should be negative 1, then 0 again.
So negative 1, 0, and 1.
Yeah.
Thank you. Long day. Okay, so let's take a look and keep going. Okay, so let's start doing our terms, right?
Yeah.
So my terms for this one, it's going to be new page, insert page, new. All right, so I have my value. So it's going to be f of pi over 2, which is 0, right?
Yep.
Plus
1.
1.
X.
So it's going to be 1 x to the 1 over 1 factorial, and it's going to be right here. It's going to be
X minus
x minus pi over 2 to the, this one's actually 1. Yeah, that's the reason why I actually said it like that. To the 1. Okay.
Oh, should it be negative?
Should it be negative?
0 minus.
Yeah, 0 minus, because it's the negative 1 from f prime.
Negative 1. Okay, sorry. 0 minus. Okay. Minus. Okay. So we got minus. So now next one is going to be
0.
plus 0 x2 over 2 factorial, and it's going to be x minus pi over 2 squared.
Then we have 1.
Then we have, actually, hold on. Oh, yes, I screwed up. Sorry. It's not, you're not putting the x on there twice. Oh, no!
Just
Undo.
Control Z.
It lives. Yes, it lives. All right. I was putting x in too many times. It's only in there once. Okay, so so it was negative 1. And there it is. So it's x minus pi over 2 first over 1 factorial. Long day. Sorry. So I was putting it in there twice. I shouldn't have. Plus next one, 0 x minus pi over 2 squared over 2 factorial. Next one is going to be plus 1, and then it's going to be x minus pi over 2 to the 3rd over 3 factorial. All right. Is that all of them? Do we made it through all those? 1, 2, first, second, third. Did I do 4th derivative?
No, we didn't.
I did not.
But it's going to repeat back to 0.
Okay, so you figured out what it's going to be, right?
Yeah.
Okay, good. All right, so let's start with my terms. So my first term, which is very ugly looking, is a 0. Is that you?
Yeah. It's like a yolk. It's like an embryo.
Anyway.
Egg.
All right, so I'm going to get,
It's like an
let's
egg
see,
and a chicken.
negative x minus pi over 2 over 1, right? Okay, this is going to be 0, 0, plus, this is going to be x minus pi over 2 to the 3rd over 3 factorial. Next one's going to be, say minus, minus
X minus
pi over 2,
or to the power
5, 5th factorial, right? Yeah?
Yes.
Okay, good. All right, so you guys got it now, right? So for these ones right here, let's go ahead and try and make a sum for this. We have a sum as k equals 0 goes to infinity. First, is it alternating?
Yeah.
Let's take care of that alternating. Negative 1 to the,
Okay.
okay, I took care of the alternating. So is alternating going to be all right?
Yeah.
Say no.
No, because we need a +1 to start out negative.
Yes, thank you. Plus 1. K plus 1? Very good.
4. 4. Okay. X minus pi
To the k.
X minus pi over 2.
to the
2k minus 1?
I thought.
Wait,
I thought it was 2K.
Isn't it k
K minus
equals
1.
pi halves for the summation?
Okay, C. Remember, this is actually, it's a Taylor series, so it's actually going to be about pi over 2. So remember what like doing, you're doing transformations, and you're doing inside, so it's going to be pi over 2 as I'm actually doing. So as I keep increasing this, if it's inside the radius, the big R, okay, if it's still inside that big R, that little c, remember when we found the u? So if it's inside there, so it's in between x and c, somewhere in there, that I'm going to get it, it's inside the radius, and remember, that's the radius of convergence. So everything inside there is going to converge, right? So what we did here is we got a value c here that is supposed to be inside my radius. So as I expand this, this is still supposed to converge because it was within my big R. Yes, or shake my head because, that's what this guy said.
yeah, it's 2k minus 1. Because then it becomes 1 times 2 minus 1 is 1.
You say 2k minus 1.
Yes. Because the first term is x minus pi, or negative x minus pi half over 1.
What is...
Oh, that's 0. That's right, that's k. So then
My
it's
first
0.
term is supposed to be k equals 0, right?
Yeah.
Yeah.
So it's gonna be plus 1.
Plus 1?
Yeah, yeah, plus 1.
Okay, let's try.
You just testing it.
I know, so that's kind of what you got to do. You write it out, and then you test to see if it works. And if you test if the pattern keeps working. All right, am I missing anything?
Well, yeah.
2k
plus 1 factorial.
You said 2k plus 1 factorial.
Because the power is the same as the factorial.
So the power should be the same as the bottom, right?
Yeah. That's like almost exactly like the McLaurin series for the sine. You just subtract pi half. Is that a rule? You subtract c from the McLaurin series for sine?
It's within a radius of convergence, right?
Yeah.
All right, so, but the only thing that's going to issue, you can't just, say that arbitrarily because you're doing it around that c value. And that c value, when you take the derivatives at that value, that might change your signs or your coefficient. So you can't arbitrarily say, oh yeah, it's always going to work. You got to actually plug and chug on some of these. Does that make sense? Is everyone okay with this now?
Yeah.
It's
It's a lot easier.
You know-
This morning I didn't understand it, but now I do.
okay. So patterns. Patterns are a good thing, and I think I'm going to. I think the other ones actually are just a lot more of this.
What's so important about the series that McLaurin named it after himself? Why?
Binomial series is not included, so this is not included. And what's so important about what?
The McLaurin series, like why is
Okay, so what did we do different with the Maclaurin series and the Taylor series?
the derivatives of values?
Okay, no, not just that. We took a function and then we expanded it so the summation of that would still be convergent. Right? So we before when, with all these other things that we were doing, we were starting with some summation and we were testing to see if it's convergent or divergent, right? But we already started with the summation, so we're really not going with the same thing. So we're actually now working backwards from the pattern or the function and getting the series or sequence out of it. Does that make more sense now?
Yeah.
So we're getting this and we're trying to make it to get to the the function, where I get the pattern, where it's eventually going to go to for whatever reason. Okay? All right, so like I said, not part of the AP exam. Like, share, and subscribe. I added it to the notes just because it was in there.